Morning, dear students. In this video lecture, we will discuss about the topic process and process states. A process is a program or a part of it in execution. Process is also known as an instant of a program in execution. We can say that it is a momentary momentary part of a program in execution. Multiple instances of same program can execute simultaneously. A process requires various system resources like CPU for executing the process, memory for storing the code corresponding to the process and associated variables, the input output device for information exchange, etc. A process is a sequential in execution. Means one of the main property of process is that it requires various system resources. The concept of process leads to concurrent execution, that is shadow parallelism. Means all the instructions are executed parallelly. The concept of process leads to concurrent execution of the task and thereby the efficient utilization of CPU and other system resources. Parallel concurrent execution means CPU can perform other tasks while it executes the current task. Concurrent execution is achieved through the sharing of CPU among the processes. A process mimics a processor in properties and hold a set of registers, process status and program counter to point to the next executable instructions of a process. A stack for holding the local variables associated with the process and the code corresponding to the process. Means uh, from this point we can say that a process can have all the properties and it requires allocation of system resources and it has a set of registers, process status and program counter to point to next executable instructions and a stack also. The structure of the process, as we have already discussed, a process contains stack registers, working registers, status registers, program counters, code memory corresponding to the process. This is the basic structure of a process. Process states and state transaction. The creation of a process to its termination is not a single step operation. Means we can say that process is done in various steps. The process traverses through a series of states during its transaction from newly created state to terminated state. The cycle through which a process changes its state from newly created to executed execution completed is known as process life cycle. Means we can say that the execution of process which changes its state from newly created to execution completed is known as process life cycle. The various states the various states through which a process traverses through during a Process life cycle indicates the current status of the process with respect to time and also provides information on what it should is allowed to do next. The figure represents the various states associated with the process. The state at which process is being created is referred as created state. The state at which process is being created or started is referred as created state. The operating system recognizes a process in created state, but no resources are allocated to the process. It means in the created state, the process is not allocated any system resources. The state where a process is inspected into memory and awaiting the processor time for execution is known as ready state. At this stage, the process is placed in ready list queue maintained by operating system. The state where in the source code instructions corresponding to process is being executed is called running state. Running state is the state at which the process is execution happens at which the process execution happen means we can say that in the running state the process is executed. Blocked state or wait states refers to a state where a running process is temporarily suspended from execution and does not have immediate access to the resources. Means this process is blocked and it cannot access the system resources immediately. The, the state will resume after it got some, we can say, some signals from outside system operating system. This is the process state and state transaction diagram. It represents creation of the state or creation of the process, then the ready state, then the running, completed, and the blocked. These are the various states of a process. In the first, process is created, but resources are not allocated. In this is the ready states, schedules for execution, and in the running state, the process is running or execution takes place and resources are allocated. And after execution, the process is complete. And if it is interrupted, then the process is blocked and it requires some outside signal to unblock it and then again ready for execution. The transaction of a process from one state to another is the transaction of process from one state to another is known as state transaction. When a process changes its state from ready to running or from running to blocked or terminated or from blocked to running, CPU allocation for process may also change. Means with change in state, the allocation of the system resources may also get changed. The process management deals with the creation of process, setting up memory space for process, loading process code into memory space, allocating system resources, setting up process control block for process and process termination or deletion. Threads. A thread is the primitive that can execute codes. A thread is a single sequential flow of control within a process. Thread is also known as lightweight process, whereas task is known as heavyweight process. A process can have many threads of execution. Different threads, which are a part of process, share the same memory, same address space, meaning they share the data memory, code memory, and heap memory area. Thread maintain their own thread status, that is CPU registers, values, program counters, and stack. The memory model for a process and its associated threads are shown in figure below. Stack memory for thread 1, stack memory for thread 2, and so on. Means this is the stack memory for the process, then data memory for process, then the code memory for process. The memory organization of process and its associated thread is shown in the figure. As we have already mentioned that threads have their own CPU registers, value, program counters, and stack. Concept of multi-threading. A process oblique task in embedded application may be complex or lengthy one, and it may contain various subprogram like getting inputs from the input-output device connected to the processor, performing some internal calculation oblique operations, updating some input devices, etc. If all the subfunctions of a task are executed in sequence, CPU utilization may not be efficient. Means to utilize the CPU in an efficient and optimized manner, we have to use the multi-threading concept. For example, if the process is waiting for user input, CPU enters the wait state for the event, and process execution also enter a wait state. Instead of this single sequential execution of whole process, if task or process is split into different threads carrying out the different in, instead of the single sequential execution of whole process, if task oblique process is split into different threads carrying out the different subfunctionalities of the process, CPU can be effectively utilized, and when the thread corresponding to input output operation enter the wait state, another thread which do not require the input output event for their operation can be switched into execution. This leads to more speedy execution of the process and efficient utilization of the processor time and resources. The multi-thread architecture of a process can be better visualized with thread process diagram as shown in figure. The task oblique process, code memory for process, data memory for process, stack registers, thread 1, thread 2, thread 3, process with multiple threads. In this, there are three threads, and each thread is executed in concurrent execution. Now, if the process is split into multiple threads, which executes a portion of the process, there will be a main thread and rest of the threads will be created within the main thread. Use of multiple threads to execute a process bring the following advantages means utilization of multiple threads in execution process have some advantages. First one is better memory utilization. Multiple threads of same process share the address space for data memory. This also reduces the complexity of inter-thread communication since variables can shared across the threads. Since the process is split into different threads, when one thread enters a wait state, CPU can be utilized by other threads of the process that do not require the event, which the other threads waiting for process. This speed up the execution of the process. And last is efficient CPU utilization. CPU is engaged all the times. Thank you a lot. In the next lecture, we will discuss the difference between a thread and a process in a tabular form. Till then, bye bye.